All right, so I'm going to have you guys get started on this and then pause the video, finish this side, and then start the video and pick up on the other side. But we've already learned that the derivative of the sine of theta is going to be the cosine of theta, and the derivative of the cosine of theta is going to be negative sine of theta. All right, so we're going to use that and the quotient rule for derivatives to find the others. And then we're going to memorize them and not have to go through the process every time. But to get you guys started, to find the derivative of tangent of theta, you're going to want to rewrite it using an identity that the tangent of theta is equal to the sine of theta over cosine of theta. All right. And then for cotangent, we're going to rewrite that as the cosine of theta over the sine of theta. I guess technically, once you do the tangent of theta, you can rewrite that as 1 over tangent of theta if you want. I know this way will work. All right, and then for secant, we're going to rewrite that as 1 over cosine of theta. And then for cosecant of theta, we're going to rewrite that as 1 over sine of theta. And then use the quotient rule on those to figure out their derivatives. So go ahead and pause the video, do that, to do your work in the middle, and then write the answer at the end like we did for the first two. Okay, so now that you've done that aside, we're going to write down what all of these equal. And we already knew from before today what the derivative of sine of x is, and the derivative of cosine of x. But now, hopefully, you know the derivative of tangent of x is secant squared of x, and the derivative of cotangent of x is negative cosecant squared of x. All right, and then for secant, the derivative of secant of x is secant of x tangent of x. And then for cosecant, the derivative is negative cosecant of x cotangent of x. All right, and then hopefully you guys saw the relationships. So if your derivative you're finding, if the original function has a co, then your derivative is going to be negative. All right, so each one of those was a cosine, cotangent, cosecant. Its derivative was negative. All right, and then if you have the derivative of sine, the derivative of cosine, you're either going to add a co or take off a co. All right, same thing for tangent. If we know the derivative of tangent of x is secant squared of x, then the derivative of cotangent is negative because there's a co, and then it's cosecant squared. All right, and then if we know the derivative of secant of x is secant of x tangent of x, the derivative of cosecant, we have a negative because it was a co, and then you add a co, so cosecant of x cotangent of x. So if you know 3 of these, you should know all 6 of them. Well, if you know certain 3, you should know all 6. All right, so let's find some derivatives. All right, so for the first one, we're going to find the derivative of f of theta, which is equal to cosecant of theta, secant of theta. All right, so let's just start with the derivative of cosecant of theta. This is going to be a negative for sure because it had a co, and then it's negative cosecant of theta, cotangent of theta. All right, and then plus for our secant, the derivative of secant is secant of theta, tangent of theta. Okay. Let's look at 2. For 2, we're going to have to do the quotient rule because we are not the quotient, I'm sorry. We're going to have to do the product rule because we are multiplying two functions together. So when I find the derivative of g of x, I'm going to leave the first one alone and then multiply by the derivative of the second. So the derivative of cotangent is negative cosecant squared of x. And then plus, leave the second one alone, and multiply by the derivative of the first. All right, and then I just clean it up a little bit. And that's it. All right, so for 3, we're going to use the quotient rule to do that. So I'm going to let 3x be blue, and I'll let cosecant of x be green. We want to find h prime of x. We're going to use the quotient rule because there's no way we can simplify that because they're not even the same type of function on the top and bottom. So we are going to do low and multiply by d high. So the derivative of cosecant is going to be the negative cosecant of x cotangent of x. Then minus high, we leave high alone. And then d low over low squared. Okay, and then we'll just clean it up a little bit. All right, now it's possible that you can just leave the answer like that. If we look at each of our terms, we can reduce them all by 3. I have a common factor of 3. So I'm going to write it like that. I'm going to divide 3 by 3. And that's good. We could factor out a common factor on the numerator, but that's not going to create anything that will help us simplify. Okay, so let's look at this one. So for f prime of theta, for this first portion, we are going to use the product rule because they both have a variable. So I'm going to leave the first one alone, multiply by the derivative of the second. Ooh, forgot. That is negative cosecant theta cotangent theta. All right, and then plus, leave the second one alone, multiply by the derivative of the first. So the derivative of theta is just 1. All right, so that's just that part. For the second part, we don't have to do the product rule because we're multiplying by a constant. So it's going to be minus because it's a co to cosecant squared of theta. All right, and then we'll clean it up a little bit. Now there's a bunch of identities in the front of your book, and I know there's a couple on your assignment where you can simplify them a little bit further because of an identity. This one, they all have a cosecant. So we could factor out a cosecant, but it doesn't look like cosecant of theta, I should say. But it doesn't look like it would make it any simpler, so I'm just going to leave it like that. All right, so let me give you your assignment.